Okay, folks, we're going to finish the concept of conjunctions, those compound inequalities that are joined by the word and. And now we're going to look at a conjunction that is written in a different form. It's a form where we will not see the word and written in the problem. But as we take a look at it, we'll see that it still is a conjunction, that the and is still going to pertain to the problem. We just won't see it with our eyes. And we'll point out what we mean by the fact that it's still a conjunction. These that we're going to look at in this video are going to be conjunctions written in compact form, in a shortened form. Again, we won't see the word and, but and will be implied in the overall statement. So let's take a look at the first of three of them that we're going to do. Here's the statement. Some textbooks will call this a three-part inequality statement. But this is an example of a conjunction that happens to be written in compact form. It's not as lengthy as the previous four problems that we looked at that visibly showed us the word and. Now, just so that you will be able to see and understand that this problem right here is a conjunction and involves the word and, just for a moment, we're going to take this problem and we're going to rewrite it. We're going to rewrite it in the manner that we saw in the first four problems. And so here's what it would look like. I'm going to start out by bringing down this focus expression that's in the center. And then I'm going to write this portion down after this 2x plus 3. We want to make sure that the meaning of our inequality symbol that we see here stays intact. So carefully, I want to share. Notice that the mouth of this symbol, the mouth, is to the side of this 2x plus 3. So when I rewrite this expression, this compound inequality out, showing you the word and, we cannot change the meaning of this, so we need to make sure that this symbol is written correctly. Now, like I just said, this mouth is to the side of this 2x plus 3. It's got to stay to the side. So it's going to be written like this. The mouth is to the side of this 2x plus 3. The mouth is to the side of this. And we'll write 1. Then and then we'll write the 2x plus 3 again. And we'll write this, which will just stay just the same. This seems here. I'm going to erase this in a moment, but I just wanted to rewrite this so that you could see that it is a conjunction and that it shows the word and. 2x plus 3. This is, you can kind of think of this as the, I know it might sound a little bit different, but you can think of this overall compound statement right here that's written in compact form. Think of it in the cabin of an airplane. Think of this 2x plus 3, as the main aisle of the plane, where the airline stewardess, the attendant will walk to and from that main aisle and helping the people on the right-hand side, and maybe helping the people on the left-hand side. This is the walk-through, the main corridor area. On the one hand, 2x plus 3 is less than 11, and 2x plus 3 is greater than or equal to 1. I want to make sure that you see this little statement right here, this one. I'm not concerned about him, because that's dead on. You can see it. 2x plus 3 is less than 11. I wrote it. And 2x plus 3, notice the mouth of this symbol, the alligator mouth, is to the side of the 2x plus 3. So I have to keep it to the side of the 2x plus 3 when I rewrite it, and I did. The mouth is to the side of the 2x plus 3. That is this. Now I'm going to erase this, because we're going to solve this conjunction that's written in compact form. We're going to solve it directly from the compact form statement. And here's what you do. Our goal is to get our x completely alone in the center of this conjunction. To get this x alone, that means we're going to have to get rid of the positive 3, and we're going to have to get rid of the coefficient 2. And so we're going to start in the main cabin, in the center, and we're going to get rid of this positive 3. So whatever I do to the center, I have to do to the right wing, and we have to do the same thing to the left wing. Sort of like a 3-part inequality statement. You got the middle, you got the right wing, you got the left wing. I'm going to get rid of that positive 3. So we'll go a negative 3 in the center. We will go a negative 3 on the right wing, and we'll do a negative 3 on the left wing, and I'll draw a line. Main cabin, center area, bring down the 2x. Bring down both of your inequality statements. There, there. Positive 11 combined with a negative 3, 8. Positive 1 coupled with a negative 3, negative 2. Now we will divide all 3 parts by a positive 2. Don't have to reverse anything, so we can just go over 2, over 2, over 2. And now we'll have x in the center is less than 4. Bring down this symbol, negative 1. Here's our solution. Now here's what I'm going to do so there will not be any confusion as to how the graph is going to be constructed and how the interval notation will go. I am going to say this right now as we're looking at this solution. This is a solution, and if any of you students are able to take this solution written in this way and immediately construct your graph, you go right after it. But it might be a little bit of a reach when we're talking to everybody that is in the class to be able to go from here directly to the graph. So at this stage, now I'm going to rewrite this. I'm going to rewrite this compact form solution, and I'm going to rewrite it literally using the word and. And I'm going to start with the x. So this is a key part. I'm going to start with the x, and I'm going to take this inequality symbol and make sure that when I write it down here, I'm not changing the meaning. The mouth is to the side of the x. The mouth has to stay to the side of the x, so I'm going to have to reverse him. I'm not reversing because I'm dividing by a negative. I'm reversing to keep the meaning of my solution intact. The mouth of this symbol must remain to the side of the x. So I'm going to have to reverse that so it will be. The mouth is to the side of the x. Then I'll put -1. Then and now we'll do this one. Now, the solution to this conjunction, you can either leave it in this form, or it can be written in this form. They both mean the same thing. I just wrote it this way so it would give a help in terms of what the graph would be. So let me put that graph right here. Get your 0. One of your endpoints is -1. Your other endpoint is a +4. Pull it out a ways. Now, let's show it. X must not only be greater than or equal to -1, but at the same time that x is greater than or equal to -1, it must as well be less than 4. So let's start with the x is greater than or equal to -1. Greater than or equal to demands a bracket, and the bracket must open to the right, and it must emanate at -1. There is the correct symbol for the x is greater than or equal to -1. And at the same time that x can be any real number greater than or equal to -1, it's got a constraint on this positive side at +4. It must at the same time be less than 4. You put a parenthesis pointing less than 4, pointing in the direction of this going to the left, and we'll shade everything in between. There would be the graph of the conjunction. Notice, folks, it's a coming together. The interval notation. I know I kind of lost that -1 right there. Let me get it there. The interval notation, bracket, parenthesis, low number, large number, done. I think I'll keep it that way when we do conjunctions written in compact form. Let's do a 6th. See, if you're going to talk about compact form, I don't think you're just going to do one. It's just not fair. You can't just do one. You got to look at it a bit. So let's go to 6. -3 is less than or equal to 2/3 x -5, which in turn is less than -1. Folks, be mindful of this. I'll say it very carefully. When you see a compound inequality that is written in compact form, it is an and. The only type of compound inequality that can be written in compact form, such as this, is a conjunction, is an and. You don't see the word and, but it's camouflaged in there. It's there. Now we're going to solve this problem from its compact form. The goal, get the variable x in the middle. We're going to have to get rid of -5 and then get rid of that coefficient 2/3. I believe I would get rid of the -5 first. I don't believe on this one that I would multiply all 3 parts by the common denominator of 3. You might forget to multiply this guy by 3. I think I'd get rid of that -5 first. positive 5 in the center, positive 5 on the right wing, positive 5 on the left wing. In the center, 2/3 x. Bring down the inequality symbol there, the inequality symbol here. Doesn't matter which wing you begin off with. 4. -8. Now folks, you can do one of a couple of things. If you want to eliminate that entire coefficient in one move, we can multiply the center by the reciprocal of 2/3 and multiply the center by a 3/2. He'd get multiplied by a 3/2, so would he. That's fine. And it's quick. I'm not going to do it that way, but you could. I'm going to get rid of the denominator by multiplying all 3 parts by 3. I know it's going to take a little bit longer, but I'm going to do it that way. Tuck. Tuck. And tucking. All 3 parts by the common denominator of 3. There. 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 We'll get those 3's will cancel out to 1's. And we'll be left with a 2x. Bring that puppy down. Bring that one down. We'll have a 12. And we'll have a -24. Now we'll divide all 3 by 2. Now we would have saved a little bit of time probably by multiplying all 3 parts by the reciprocal, but we'll still get it. Now we have x is less than 6, and x, watch how I say it, and x is greater than or equal to a -12. Now you see that might bother some people when I say and x is greater than or equal to -12, because you folks are going to look at it and you're going to say, well, that means is less than or equal. It does if I'm reading it from left to right. But if I'm reading it from the center aisle of the jet, if I'm reading it from the center to the left wing, I'm reading x is greater than or equal to -12. But I'm going to take care of that right now because we're going to rewrite it. X, the mouth has to stay to the side of him, so I'm going to have to reverse. They're the same. If you're asking, do I have to write this or can I just interpret this? You interpret that if you're able to do that. They're both valid statements. Now the graph. Just get a 0 on there. Take it down to a -12 anywhere. And take it out to a +6 on the positive side. And now we'll do it. On the one hand, x must be greater than or equal to -12. So you're going to need a bracket at -12. And it's got to open to the right because the inequality symbol is opening to the right. And at the same time, x has got to be less than 6. So it's got to project less than 6, the parenthesis you shade in between. Your interval notation, bracket, -12. Comma 6, parenthesis, the Mona Lisa is done. It's finished. Again, if you can go from the compact form solution to him, you go right after it, because I ordinarily would, but I'm talking to several people, and I don't want confusion. One more, and the compact form type will be done. I want you to see it. 7. 10 less than negative 6x plus 2, which in turn is less than or equal to negative 4. Compact form, folks. You don't see the and, but it's there. Get x in the middle. Get rid of the 2. Negative 2, negative 2, negative 2. Negative 12 is less than negative 6x, which in turn is less than or equal to negative 6. Now we're going to have to divide the center aisle by a negative. That means those are going to reverse. So we'll reverse them. Don't put that fraction bar there. You bring down that negative 6x in a fresh way, and you show that you're going to divide it by negative 6. Reverse him. Reverse him. Reverse him. Bring down your negative 6, and he's going to get divided by negative 6. Bring down the negative 12, and he's going to get divided by negative 6. We have our x is greater than or equal to 1, and you see, not only is x greater than or equal to 1, but x and x has to be less than 2. Now if you want to rewrite it, literally showing and, x. The tip has to be the side of the x. You're going to have to reverse it. So the tip will remain to the side of the x. And x is greater than or equal to 1. He fits the graph. Get a 0. You got to take it out to 2, and you got to take it out to 1. On the one hand, x must be less than 2. X has got to be less than 2. But at the same time x is less than 2, x must as well be greater than or equal to 1. Bracket. Shade in between. There's the graph. Bracket, parenthesis, comma, the small value, 1, the larger value, 2. Put it to bed. Done. Now, folks, that takes care of letter A in 4-2, solving conjunctions. There's 2 forms. Form 1, the first 4 problems that we did, we literally wrote out a compound inequality visibly showing you the word and. But in problems 5, 6, and 7, we looked at a conjunction that was written in compact form. You'll need to know both. You'll need to know both. We solved, we graphed, we wrote an interval notation. In the next video, we'll go to letter B, and we'll look at the compound inequality that is dealing with the word or. We've done and. We'll do or. Take care. Bye-bye.